Okay, so we are starting our midterm exam review, and this is Unit A. This looks very similar to the questions that were on your Unit A test. So just let's go through these. So here, write the equation for a line in slope-intercept form. Slope-intercept form, of course, is y is equal to mx plus b. So it's parallel to this line, so that means that m is equal to 5 in this line, so m is also equal to 5 here, and it's going to take these two same points. So actually, if I start off with point-slope form, so y minus y1 is equal to m times x minus x1, then I can plug in these points. So I get y minus 7 is equal to negative 5 times x minus 2. And so I get y minus 7 is equal to negative 5x plus 10. And then I can add 7 to both sides. So I get y is equal to negative 5x plus 17. And that's my answer for that one. Notice if I start with point-slope form, it will actually fall back into slope-intercept form just by me solving for y, isolating the y. And that's it. So for the next one, they give us a point and the slope. So yet again, I'm going to use point-slope form. Y minus y1 is equal to m times x minus x1. And so I can plug in my values. So y minus a negative 5 is equal to negative 1/3 x minus 6. So I get y plus 5 is equal to negative 1/3 x. Negative 1/3 times negative 6 is plus 2, because that's negative 6 divided by negative 3. And then I can subtract 5 from both sides. So I get y is equal to negative 1/3 x minus 3. And that is my answer for that question. Next up, I'm given 2 points. So what I actually need to do first is I need to find the slope. So slope is y2 minus y1 divided by x2 minus x1. So that's just the difference in the y's, which is 8 minus 2, divided by 7 minus 6, which actually turns out to be 6/1, or 6. Knowing that, I can yet again use point-slope form and plug in my values. Here I can choose whichever point I want. 2 is a little bit lower, so I'm going to choose the first point, but you can absolutely choose the second point. So y minus 2 is equal to 6 times x minus 6. So I get y minus 2 is equal to 6x minus 36. And then so y is equal to 6x. If I add 2 to both sides, I get minus 34. So that's my answer there. For the next one, for these two questions, we want to evaluate this function. So f of x is equal to 2x squared minus 5x. So when f is f of 6. Well, f of 6, notice I replaced the x with a 6. So I'm going to replace my x with a 6. I just evaluate this. Order of operations says I square this first. So I get 2 times 36 minus 30. So that is 72 minus 30. So that means that f of 6 is equal to 42. Notice I write my answer as f of 6 equals, not f of x, because f of x equals this formula up here. F of 6 is specifically 42. I'm going to do the same thing with negative 4. So f of negative 4 is equal to 2 times negative 4 squared minus 5 times negative 4. Order of operations, I squared the negative 4, so I get a positive 16. And negative 5 times a negative 4 is a positive 20. So 2 times 16 is 32. So I get that f of negative 4 is equal to 52. And that is my answer there. So really straightforward here. This is basically just a substitution type deal where we're plugging in values for x. Next up, we have a piecewise function. So we actually have to decide which line we're going to plug in. Whenever x is less than 2, we're going to use this first line. But whenever x is greater than or equal to 2, we use the second line. So here, f of -3, well, because -3 is less than +2, I use that first line. So 5 times -3 minus 2. So this is -15 minus 2. So I get that f of -3 is equal to -17. Simple enough. Next up, f of 5. So f of 5 is equal to 1/2 of 5 plus 7. I use this second line because 5 is greater than 2. So I get 5/2. I need a common denominator. So 7 over 1 is 14 over 2. So I get that f of 5 is equal to 19/2, 19 over 2. And that's my answer there. So just two nice questions here going through. Again, nice substitution to evaluate. We want to decide if y is a function of x or not. So what I can actually do is solve for y. So -3y is equal to -2x squared plus 9. Y is equal to 2/3 x squared minus 3. Yes, this is a function. Notice this is a quadratic function. We've seen this before. The highest exponent is 2, so this is a quadratic function. No matter what I plug in for x, I'm always going to get, well, so the main difference between a function and not a function is our value. So remember, if I have a graph, the vertical line test means I can draw a vertical line through any function, and it's only going to cut once. This means that there's only one y value for an x value. So here, if I plug in an x value, what's going to happen is I'm going to get one y value. I'm not going to get two y values. To show the difference, let's solve this next one. So I get 2y squared is equal to 5x plus 10. Divide everything by 2, so y squared is equal to 5x, so 5/2 x plus 5. And then take the square root. So y is equal to, well, because I take the square root, I need a plus or minus. So I get 5/2 x plus 5. Notice, if I plug in, let's say x is 2, I get the positive square root of 10 and the negative square root of 10. I get two y values. So that's like if I have this function here and I draw a vertical line through it, notice for one x value, I get two y values. That fails the vertical line test. So number 9, no, that is not a function of x. So be very, very careful there. So really you're just looking out for the y squared because you know you're going to have to take a square root. All right, and so moving on. Relative maximum with this picture. Well, the relative maximum is going to be at -1, 2. This is a turning point, right? Whenever we have a relative maximum or a relative minimum, it is a turning point. So the relative maximum is at -1, 2, and the relative minimum is at 1, -2. So again, another turning point. On which interval is the function increasing? So where is it going up? Well, it's increasing starting at -infinity, and it's going up all the way until x is equal to -1. Then it starts decreasing. And then yet again at this turning point, this relative max, it starts increasing again at 1 and goes all the way up to infinity. Where is it decreasing? In between. So from -1 to +1. Notice that if I put these together, 12 and 13, I'm going to get negative infinity to positive infinity. This goes on and covers the entire domain. And speaking of domain, what is this domain? What could x be? Anything from negative infinity to positive infinity. There are no breaks in this graph. It goes on forever. You know, assuming these continue, but they do. Technically, we need arrows there, but we can infer that from the graph. Okay? So make sure you review. We did a lot of problems like this, so it did cause some confusion for a number of you. So if you are confused, make sure you do check that out. All right, so we want to find the domain of these functions. So domain is what can x be. So to find the domain, sometimes it helps to figure out what can't x be. And x is underneath, this is underneath the square root. So I can't take the square root of a negative number. So that means anything underneath the square root, in this case x minus 7, must be greater than or equal to 0. Square root of 0 is 0, but anything less than that is imaginary. So that means that x must be greater than or equal to 7. So writing this in interval notation, because it's a greater than or equal to, it gets a bracket. I start with 7, and everything greater than that, up to infinity. So there's my domain. This is the denominator fraction. A denominator cannot be equal to 0. It can be positive, it can be negative, but it can't be 0. So this x minus 9 cannot be 0. So that means that x cannot be equal to positive 9. So that means I go from negative infinity all the way up to 9, not including 9. That's a parenthesis, not a bracket. And then again, I go from 9 to positive infinity. So there's our answer there. So when you're looking at these, what's the domain going to be? Remember, domain means what can x be? What can you plug in? So sometimes it's going to be a little bit easier, rather than trying to figure that out, it's going to be easier to ask, well, what can't x be? And go from there. Here on the graph to the right is a function of the absolute value of x. So what we want to do is graph the function 2 times the absolute value of x plus 3 minus 1. So we have these transformations. So what we're going to do is we're going to take every point. We are going to shift left 3. We're going to shift down 1, so negative 1. And then we're going to stretch by factor of 2. Basically, we're going to take each y value multiplied by 2. So let's start with this first point here. Better yet, let's start with 0, because I'll show you how we can check this. So if we start with 0, we take this point. We're going to shift to the left 3. 1, 2, 3. We're going to go down 1. And we're going to stretch it by a factor of 2. So that means here I'm at y is negative 1. So if I stretch by a factor of 2, I multiply that by 2 and get negative 2. So that's now 0. Well, when x is 0, here I get 0. But what about here? What do I get here? Well, I get 2 times the absolute value of 3, which is 6, minus 5. So I did not do something right. Let's see. So because I'm here, I'm going to go to the left 3. I'm going to shift down 1. And I'm going to double that. I don't know why this is not working out. So if I start at x is 0, get the absolute value of 3 times 2 is 6 minus 1 is 5. So I should get 0, 5. Right. Let's see. Oh, no, I'm sorry. That's why, because, I'm sorry, guys. This is actually not correct. So actually, I'm up here. So first off, I take this y value and I double it, right? So 0 times 2 is 0. Then I move to the left 3, and then I go down 1. So that point moves there. What I was doing before, I was plugging in x is 0. But x moved, didn't it? X is negative 3. Excuse me. So 3 plus, or sorry, negative 3 plus 3 is 0, times 2 is 0, minus 1 is here. So when you're checking your work, make sure when you plug in your x value, you plug in the new x value. See, good thing I checked that. See, I was just testing you guys. That's all I was doing. All right, so we shifted this point the same way. So here, let's shift this point. So to the left. So we're going to first double this. So right now it's at y is 1. Now it's at y is 2. And then what I'm going to do is I'm going to shift to the left 3. 1, 2, 3. And I am going to go down 1. So now my x value is at negative 4. So when x is negative 4, y should be positive 1. With this value here, I'm going to shift 2, or I'm going to stretch by a factor of 2 first. So y is 2, now it's at y is 4. I go to the left 3, 1, 2, 3, and then down 1. Notice between these points I get like a little slope of negative 1. Well, now I have this slope of negative 2. Everything's doubling, and that's because of that stretch factor. If I take this point, double it, move to the left 3, 1, 2, 3, and then down 1. And then take this point, double it, move to the left 3, go down 1. And I actually end up getting this very nice graph, which I can use a straight line tool. There you go. There you can see when x is 0, I get y is 5. Oh, that's an embarrassing mistake. But I won't edit the video. Maybe I should. But that's all we got to do there. So make sure you can understand the transformations that are happening and then how to shift the points. Now, to better emphasize what's going on with the transformations, we have this. So here we have parent functions and transformations. So if the parent function is y is equal to x squared, and I have this transformation, the transformation is shift down 6, because what I'm not doing is I'm not moving the x. Notice that for this problem up here, the plus 3 is with the x. It's within this absolute value. So if I had this in parentheses next to the x and that was squared, then that would be a shift left or right. Because it's after the f of x, is a shift down. For number 19, there are actually two transformations. I'm shifting to the left 3. So just like the problem up above. Then I have this negative on the outside, this negative f of x. So whenever we have a negative y value, that means we are going to flip along the axis. Now, if we have a negative f of x, so a negative y value, that means we flip along the x-axis. If we had a negative x value, so if this were absolute value of negative x plus 3, that would be a negative x, so we'd be flipping along the y-axis. And then here, we can see that we have this stretch. So we're multiplying, so that means we stretch by a factor of 2. And we're going to shift to the left 5. So lots of transformations we looked at. Make sure you are familiar with them, how they move, how to go through this, how to work through this. And that will be of tremendous help to you for the midterm exam. We have also these combinations and compositions of functions. So here, f minus g of x, this is really just the same as f of x minus g of x. Remember this notation. This does not mean multiplication. So this is 5x minus 4 minus g of x, which is x squared minus 4x minus 2. I put this in parentheses because I'm subtracting the whole thing, which means that negative sign distributes in. So I end up getting negative x squared plus 9x minus 2. And here I have g minus f of x. So this is x squared minus 4x minus 2 minus 5x minus 4. Same deal. I put that in parentheses. So now I know I am distributing that exponent like so. I get x squared minus 9x plus 2. Hey, look at that. They're exact opposites of each other. Pretty cool. That's all you got to do. So make sure you understand this is not a multiplication thing. This is g of x minus f of x. And this is f of x minus g of x. And I'll write that out here. And this is multiplication because notice this is f. Actually, this is not multiplication. Oh, no, I'm sorry. It is. Sorry. Oh, boy. Oh, I'm making too many mistakes today. F times g of x. So this is f of x times g of x. And so what we get is x minus 5 times x squared plus 3. So we're just going to FOIL this out, multiply this out. So we get x to the third plus 3x minus 5x squared minus 15. So we can write that in standard form. Whoops. With our exponents in descending order. So x to the third minus 5x squared plus 3x minus 15. And so if we have g of f of x, so we have x, well, we start with g of x, right? So g of x is x squared plus 3, but we're replacing the x with f of x. So that's x minus 5. So now we just clean this up. So we get x squared minus 10x plus 25 plus 3. So that's x squared minus 10x plus 28. And so that gives us our final answer there. So this is a composition of a function where, just like we did before, where back here for these problems, f of negative 3, f of 5, we replaced the x value with the negative 3 with the 5. Now we're just replacing the x value with a function. All right, then we want to find the inverse of this function. So if I have f of x or y is equal to 5x minus 4, what we want to do is we want to switch the x and the y. So we get x is equal to 5y minus 4. We add 4 to both sides. Now I'm going to switch this around and then just say y is equal to x plus 4 over 5. Notice here, all I have to do is just divide. I don't really worry about what else is going on over here. But this is not y. I need to put this negative 1 exponent to really show that it is the inverse. So make sure you don't forget that because I did take points off on the test, and I will again for your midterm exam. Now if we do want to verify, so here we want to verify that f of x is an inverse of g of x and g of x is an inverse of f of x. To show that, we need to show that the compositions of the functions both equal x. So we need to show that f of g of x is equal to x and g of f of x is equal to x. So g of x plugging in, so 2x plus 5 minus 5. over 2. I can subtract these 5s first, so I get 2x over 2, and so this equals x. And over here, g of x is 2x plus 5. With the x, I plug in x minus 5 over 2. The 2's cancel out, so I get x minus 5 plus 5, which is just x. So because I get this, that verifies. So because f of g of x and g of f of x both equal x, that is my answer. So that's it for the Unit A midterm review. So make sure you also go through your test, homework questions that we had, and your quizzes. But if you can do this is a really good start. If you need more practice, view those other resources, manage your time effectively, and good luck.